Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us see about the introduction to Smith chart. So, in transmission lines, there are tedious manipulations involved in computing the characteristics such as reflection coefficient, VSWR, and input impedance of a transmission line. So, by means of Smith chart, we are going to reduce the tedious manipulations involved there. And this Smith chart is nothing but a graphical representation of impedance of the transmission line and corresponding reflection coefficient. The Smith chart is constructed with a circle, okay, with a circle having the unit radius. Reflection coefficient is less than or equal to 1. Within that particular circle only the Smith chart is constructed, and the relation behind the construction of Smith chart is reflection coefficient at the load gamma is equal to ZL minus Z0 divided by ZL plus Z0. So this reflection coefficient is a complex number which has both magnitude as well as angle, and I can write in the rectangular form real part plus j imaginary part. Okay, so let's see the how the transformation is being done from the impedance graph to the reflection coefficient graph. Generally, the load impedance I can write as resistance plus j. The reactance part, resistance as well as complex number as a reactance it will have. So I can write in terms of magnitude and angle. Okay, e power j theta ZL. So R is the real part of the load impedance, X is the imaginary part. The R value or the resistance value ranges from 0 to infinity, whereas the reactance value it ranges from minus infinity to plus infinity. So at any point we can represent both the magnitude and angle. Similarly, the same reflection load impedance, it can be mapped to the reflection coefficient at the load in the same manner. Magnitude as well as angle I can represent, same I can represent in real part and the imaginary part. Okay, so the magnitude of the reflection coefficient, we know that it ranges from 0 to 1, whereas the angle of reflection coefficient varies from minus 180 to plus 180 degree. This we already saw in the fourth module. So now let us see, to represent any point on the Smith chart, we have to first plot the load impedance. So we have to plot by taking the normalized load. Small ZL is nothing but ZL divided by Z0. We have to normalize it. So that will be the combination of small r circle and one j x circle. Okay, so why we go for this normalization instead of having separate Smith chart, because each transmission line have the different characteristic impedance, ranging from 50, 75, 100, etc. So no need to go for individual Smith chart for in separate characteristic impedance. So we are going to use a normalized Smith chart by normalizing the load impedance corresponding to the given characteristic impedance, right? So this is a complete view of the Smith chart. So the outermost circle is gamma equal to 1 circle, that is written here, and the center point is reflection coefficient is 0. Okay, and the unit radius of the reflection coefficient is represented here. So the magnitude ranges from 0 to 1. Whereas if I see the phase, I can plot the Smith chart as the polar form of reflection coefficient. So here the real part of reflection coefficient gamma is there in the x-axis. In y-axis, the imaginary part of reflection coefficient is given. So as we move along the Smith chart, we can see from in the anticlockwise direction, reflection coefficient angle varies from 0, 90 and 180 degree, and in the below the axis we can see the negative angles represented. And one more thing to note, at the center reflection is 0, right? So it is a matched condition, whereas to the right of the Smith chart we can see the value is 1 comma 0, that is angle is 0 degree, magnitude is 1. That means it's an open circuit condition where we can have maximum impedance. And here in the left hand side we can see angle is 180 degree, so the same magnitude is same 1 only, because of the 180 degree angle it is negative. So this is a shorted condition. So open circuit is towards the right, short circuit is towards the load. Okay, hope you understood how the Smith chart is constructed and what are the basis of converting from impedance plot to the polar plot. Happy learning. Thank you everyone. We will meet in the next session.